We feed the world with a very small number of basic staple food crops. And then all of those are severely impacted by rising temperatures and by extreme events. And extreme events are particularly related to droughts and floods.
Globally, crops lose about 40% to diseases and pests every year. About 15 years ago, that number was at 25%. We're not doing better, we're doing worse. And the reason is climate change.
Best ways to destabilize society, to make people unhappy, to really struggle politically, is to increase food prices. Partly driven by the drive for biofuels, partly driven by some bad yields.
We are now entering a phase where the overall productivity growth declines to a point that we might even see a complete end of productivity growth.
Population growth is happening very quickly and accelerating. The rate of meat consumption is accelerating, increasing very quickly. Yet the amount of farmland that we have to feed everybody is fairly fixed. We have an imbalance between the demands on our food system and the actual ability of our food system to produce that.
When we think about greenhouse gas emissions, we usually think about exhaust pipes or smoking chimneys. But it's actually our food system which alone is responsible for roughly 1/3 of global greenhouse gas emissions.
Global food production, global agriculture is going to have to adapt to a warming climate. We've gone through 1.5. Hopefully we can keep the world below 2, but that is going to need some quite radical changes.
In many cases, what we see is whole-scale transformations of landscapes where one type of ecosystem transitions rather abruptly and disruptively in the form of a major disturbance, like a high-intensity wildfire or catastrophic die-off, to something completely different.
There is so much stuff that we can do and that we should do. The point is there's not going to be the one or two big solutions. It's really going to be kind of a mosaic of solutions that need to work with each other. But to find that mosaic, you really need an understanding of how the systems work.
The combination of an energy transition, healthy food, food waste is reduced, and sustainable production practices, all of which is proven to work, all of which gives social and economic benefits. Combine that together, and you're actually able to transition back within the safe operating space within the next 30 years.
For 10,000 years, since the development of agriculture, farmers usually would grow in a particular area what basically the geophysical environment would allow together with existing technology at the time. So if we then have climate change, if we have huge biodiversity loss across the area, if we have water pollution happening everywhere, if we have soil degradation happening everywhere, feeding ourselves from a degrading environment, just as an example, in the moment about 50% of ice-free landmass is used for feeding humans, for agriculture basically. So if we have deteriorating environmental conditions, that will have, and already has, quite an important impact on what can we grow, how can we grow it, if we have moving climatic zones, which we're seeing, if we have more droughts, more floods, that will have very important implications how we can feed ourselves in the future.
Bayer is forefront of innovating in the agricultural space and certainly has the broadest global reach of all agricultural input companies in the world. We have a lot of skin in the game because we're a business and the success of our business depends on the success of farming communities around the world. So we are very, very close to what I would say is the ground zero of climate and agriculture. And climate change is affecting agricultural outputs in ways that are no longer in line with the experience of the past. So past performance is really not a good predictor for the future in agriculture anymore. That's a big deal. For breeders, for people who try to breed crops that are able to adjust to higher temperature, a constant kind of trajectory of temperature increase is something they can handle. But if the intervals are getting smaller and smaller and smaller, then the breeding cannot keep pace with the temperature increase. And what I look at is a situation that gives me reason to believe that we are now at that inflection point where we are no longer able to adapt to climate change in ways generations before were able to do that.
The system is sort of very fragile. The vulnerability comes about because it takes up so much land, it takes up so many resources in terms of fertilizers, pesticides, herbicides, that if any part of that chain breaks, say your fertilizers double because Russia invades Ukraine, then that knocks on in price through the whole system. Other vulnerabilities come about because a lot of the crops that we currently grow and a lot of the animals that we rear are actually monocultural. So they have little resistance to diseases if they're all of the same type of crop. We see issues with, for example, coffee, with bananas, where we have sort of diseases that are spreading like wildfire because there's no genetic diversity, so they're not very resilient.
The more the climate gets extreme, the more diseases you're going to get. The more the climate change happens and now you have different temperatures, now your crops are adapting to different diseases. So all these things, right, in a stable system, great, you know exactly what you're going to get. But in a system that's changing and so volatile, the environment is changing with it. And I think that's the reality of what we're seeing is things are changing in a way that farmers can't necessarily adapt to quickly. And if you think about the products that they have, well, the fungicides, every fungicide that we use is at least 50, 60 years old. We haven't created new fungicides in a long time. So let's assume temperatures change and places get warmer, disease is going to be more present because that's what fungus likes, warm, humid environments. Do we have the right products in order to address that? Are those products going to work in this new environment? Basically, it's kind of like the chess game is changing, but we're very late to adapt to any of these changes.
The last 10 years are an indication that something is changing. Economically speaking, agriculture is a success story where in every decade you had an annual increase in productivity of around 2%, a lot of that being driven by breeding. And in the last 10 years, you see that productivity increase no longer happening. So we have to come to grips with a world where the agricultural productivity goes down, but it's also a world where the demand for agricultural products goes up.
Remember that we have in 2024 reached for the first time 1.54 degrees Celsius. We've just touched even beyond 1.5 degrees Celsius. Munich Re assesses that 2024 is the most expensive year ever in terms of impacts from extreme events. And agriculture, loss of yields, is one of the big losers, agricultural enterprises around the world.
At the same time, and that's the other side of the story, the food system is also one of the biggest emitters, for example, greenhouse gas emitters. So about 25 to 30% of global greenhouse gases.
The agricultural system in the world is the number one cause by far for breaching planetary boundaries. It is the single largest cause for greenhouse gas emissions, 30% of greenhouse gas emissions originating from the food system, and we are well outside of the safe levels for the climate boundary. It's by far the single largest cause for loss of biodiversity because of the expansion. It's the number one cause for expansion of human-managed land into intact nature. It's the number one cause for transitioning forest systems, and we've identified the tropical forest systems, the temperate forest systems, and the boreal forest systems as key Earth system regulating biomes for the stability of the planet. And it's agriculture that is threatening, particularly to the three big tropical forest biomes, the Amazon rainforest, the Congo rainforest, and the Indonesian rainforest. It is the number one consumer of fresh water. So 70% of the withdrawals of water from all the blue water, meaning the water in rivers and lakes and groundwater, is for irrigation. So it's like the number one use of fresh water. It's a major use of chemicals through pesticides, all forms of pesticides, herbicides and insecticides. So the novel entities boundary is significantly impacted also from agriculture. It is actually part even of the aerosol loading boundary because so many farmers in the world still use slash and burn practices. So you have these enormous smog clouds coming from burning of land, which impacting on air quality and human health, but also impacting on monsoon rainfall systems. So when you look at all the boundaries, where 7 of the 9 boundaries now are breached, all of them are heavily driven by the food system. which means that if we can transition the global food system or the agricultural system from the current unsustainable production practices to sustainable production practices, you would actually have a significant chance of pressing yourself back within the safe operating space of the planetary boundaries.
The transformation of the food system is a very powerful lever to reduce greenhouse gas emissions. If we would just transform the food system without changing anything in the other sectors like energy or transport, we could reduce global warming from 2.1 degrees in the year 2050 to 1.85 degrees. So that keeps us below the 2 degrees before 2050. However, it's important to note that the emissions from the other sectors would lead to a continuous increase in the temperature so that we would reach the 2 degrees later in the century. So, of course, the best solution is to reduce emissions in all the sectors.
It's quite astonishing how much we have underestimated how warm the world could get in terms of extreme weather events. When the UK Climate Change Risk Assessment report came out in 2021, they found that the chance of breaching 40 degrees before 2040 was 0.02%. That was the chances. And we then breached 40 degrees in both rural and urban areas in 2022. So there's this dramatic underestimation of the heat and the extremes that we could experience from climate change.
The problem we have today, though, is not just the temperature increase. It's the rate of temperature increase. In other words, the temperature increases ever faster. The intervals to move from 1.5 to 1.6 to 1.7, maybe to 2.5, will be ever shorter. And that is a problem for everybody in the agricultural system. It's a problem because the old methods to kind of deduct and think about how climate will affect weather are no longer working. But it's also a problem because even with everything we do in plant breeding, it's harder and harder to adjust the crops for these situations.
If we would magically succeed in phasing out fossil fuels, would we be able to hold the 1.5 degrees Celsius limit in the Paris Agreement if we continue producing food as we do today? And the answer is no. Actually, the food system would, on its own, breach the 1.5 degrees Celsius limit. And the reason for this is not only the 30% greenhouse gas emissions that originate from the agricultural system, where then methane and nitrous oxide would be the primary ones, because you could assume that if you phase out fossil fuels in the global economy, then of course you would no longer run tractors with diesel either. But even if you succeed with decarbonizing all use of fossil fuels, even in the agricultural sector, just the methane, the nitrous oxide, and the land degradation would be enough to push us beyond 1.5 degrees Celsius. So, in summary, there is no safe Paris climate future unless you both phase out fossil fuels and transition the global food system.
I tend to think of climate change in terms of, it's not a hard division, but sort of three pots of risks and things. One which we see at the moment, which is the increasing frequency of extreme events. I'm worried about them. I'm worried about how they might coincide with non-climate shocks, geopolitical shocks in particular. Then I sort of think about the middle term consequences, the facts that global food production, global agriculture is going to have to adapt to a warming climate. And then finally, and as I said, I am an optimist, but I still do worry about major events. There are some nasty tipping points that could occur where climate change causes effects that substantially undermine our capacity to feed the world. These shocks would be sufficiently outside the domain of the way we think, the way we model the food system. We would be in a very different regime.
When we look at big tipping points around the world, the estimates for the moderate risk of that in 2001 at around sort of 5 degrees of warming, we'd see those moderate risks. Nowadays, that's at 2 degrees. And we see that across all of these different domains. And we also see that in food systems. So when you look at the different studies, they're finding that the climate signal or the climate impacts on the food system are coming sooner and harder than we first thought.
We're causing global environmental change, and climate change is something that affects all of us on planet Earth. We're all equally impacted. So we're all sitting in the same boat. And not only that we share the same atmosphere, and it doesn't matter who pollutes, it all affects us. We also depend on big, what we call tipping element systems, the large biophysical systems on Earth that are able to buffer and reduce the impacts of climate change. And the Amazon rainforest is one of them. That's one of those big systems that sucks up carbon, stores carbon, regulates rainfall, connects to the monsoon, is one of these big players of operating the stability of the planet.
The Amazon rainforest, it completely dominates the sort of atmospheric hydrology of South America. If it were not there, the weather patterns would be completely different. And so we would lose one of the major breadbaskets of the world, which would have effects on the global food system. We do not know what would happen if, say, you had shut down South America. And we know that the effects wouldn't be just restricted to South America. There would be the risk of multiple breadbasket failure.
Every human being on planet Earth depends on a stable Amazon basin. All the children and future generations depends on a stable Amazon basin. So it's in all our interest not to destroy the Amazon. But with the livestock production system we are very rapidly pushing the whole Amazon system closer and closer to a tipping point. And the latest assessments show that we've cut down something like 17% of the canopy area of the Amazon basin. Most assessments today place the tipping point at 20 to 25% of canopy loss, and at 1.5 to 2 degrees Celsius of warming. And we are today at 1.3 degrees Celsius of warming at a 10-year average, and we are at 17% of deforestation. So we're moving very rapidly towards a high-risk point on the Amazon. What is driving this? Largely agriculture.
We tend to see extreme heat events and droughts concurrently in different parts of the world. And there's evidence that today we're more frequently seeing overlapping droughts and overlapping unprecedented extreme heat waves simultaneously in different staple crop regions of the world. So the idea is that if the staple crops fail in one part of the world but not in others, there's some resilience due to international trade. You can ship those staple crops from one place to another and alleviate the shortages elsewhere. But if you have simultaneous failures due to extreme weather events in multiple regions at the same time, all of a sudden now you have a much greater problem, because now not only do you have a crop failure in one region, alternating different regions or rotating, but you have a crop failure in multiple regions simultaneously. And so it makes it much harder for one region to supply another when there are more isolated crop failures.
If we have multiple breadbasket failures happening, of course, there's a big problem with supply. Yeah, we've seen it a little bit when the Ukraine war started. One of the first things that the UN came in and negotiated was that the grains from Ukraine could still be brought down to countries in Africa, because they depended so much on the grain production coming out of Ukraine. That's a sign of how codependent basically these two different regions are.
The chances of what's called a multi-breadbasket failure, this is a sort of a fairly dramatic reduction for maize or for corn. Before climate change, we would expect that once every 16 years or so. And you'd kind of expect that. Some years you just get a bad year. When we go to 1.5 degrees of warming, that goes up to once every 3 years. And at 2 degrees of warming, that goes up to once every 2 years. Now that's one study, but the other studies on this are also showing that the increases in these breadbasket failures increase more rapidly up to 1.5 degrees and then a little bit more up to 2 degrees. So we're moving through this period at the moment where we're going to be seeing these impacts on yields fairly regularly.
So there's about 220 million acres of soybeans grown every year. globally. Most of them in the US and Brazil. There's a few other countries as well. For those crops, the yield loss in the US alone for diseases and pests is about 25% for soybeans. And globally, crops lose about 40% to diseases and pests every year. You're wondering about, is this getting worse? We've been tracking this from the UN data. About 15 years ago, that number was at 25%. So what happens is there's going to be fungus in the field all the time. Diseases are present all the time. There's thousands of different fungi out there, so it's not like you're tracking one. At some point, the right conditions will happen, which means the plant host is ready to be infected, the disease is present, and the weather conditions are right. And when all those things happen, you can get an infection. And that infection is going to reduce yield. But the problem is you won't see that happening until weeks after the fact. So by the time they actually see the symptoms, there's nothing you can do. All the yield damage happens.
We've got these sort of chronic impacts of pests spreading more as we have warmer and warmer temperatures. So the thing with pests is that they don't actually seem to reduce in range, they just increase. And the reason is because as the world warms, they move into the higher and higher latitudes, so further north and further south. What that means is that those pests then can eat the crops and then reduce yields again. And so some estimates suggest that we could see 10, 15% crop yield losses for every degree of warming due to these pest spread.
There are counter forces when it comes to climate change and the productivity or yields or ability of agriculture to produce food. Because on the one hand, you paradoxically have a positive effect called carbon dioxide fertilization. So what happens is that we burn coal, oil, and gas, we cut down forests, it emits carbon dioxide, we load the atmosphere with more carbon dioxide, and that becomes like a doping, powering up or accelerating the photosynthesis. Because the photosynthesis is carbon dioxide plus water equals sugar, which then gets transformed to all the components that becomes the biomass that we eat in different forms in our diets. Now, with more carbon dioxide, the models show that many crops, most staple food crops, actually increase their yields. So you have a positive CO2 fertilization effect. But on the other hand, the dominating factor is that it has a negative impact, that you can get, in most scientific scenarios, relatively middle-of-the-road scenarios, we're talking of reaching 2 degrees Celsius by mid of the century, we can talk between 5 to 25% reductions in yields. And the crop that most likely is most affected of that is maize. Maize is, as we know, a dominating staple food crop in tropical regions in the world. And this is because this is a C4 crop, which does not have such a high CO2 fertilization benefit, but has a very, very strong impact of the extreme events. And remember that maize, sorghum, millet are inherently, even before human-caused climate change, cultivated in regions that are right at the margin of where you can really even produce food. So if you go to the Sahel, for example, you find, farmers depending entirely, their whole livelihood depends on 20 rainfall events during a very, very limited rainfall season. You have 400, 500 millimeters of rainfall in semi-arid, dry savanna regions. You're just at the fringe of the Sahara Desert. Millions of people have been living there for generations. If you just add a little bit of more droughts and dry spells, a little bit less water, and that system can collapse.
In 2024, the yields for wheat in France were at levels of the 1980s. So it's a generation of productivity increase, a very significant productivity increase that was no longer visible. That is cause for alarm because France probably is home to the most sophisticated wheat growers in the world. You always have a bit of yield fluctuation, but this one is dramatic. Another other example is corn production in Brazil. Here, the reason is not necessarily heat, but rain didn't come at the right time. The same is true for one of the bread baskets in Africa. It's, for example, Zambia, which suffered massively from droughts. Whether it's too much water, too little water, whether it's too hot or whether the water is dirty, these are all factors, and all of them can show themselves in different ways.
We read in the media about these devastating fires, but it always starts with water. It's all about water. And what happens is that first temperatures go up, precipitation goes down, evaporation increases, so you basically dry out the soils, you dry out all the above ground vegetation, and then at a certain point a spark starts the fire. The system is so primed up for burning because of the drying out, there's no more water, it's bound to burn.
When we talk about the effects of climate on agriculture, we need to look at water. We need to look at, is there too much water? Is there not enough water? Is the water polluted, dirty? And is the water leading to conditions that are too hot? So, is there too much, too little, too dirty, too hot? These are the four vectors one needs to look at when assessing the climate effect on agriculture.
We are very careful in our logical science to distinguish between blue and green water. So what happens is you lose all the green water. The blue water is the water in groundwater, in rivers and lakes. Those go down as well, but the key issue is the green water. The green water is the moisture in the soil. And that is what roots can take up. That's what organic matter holds. That is what drives the photosynthesis. That's what keeps vegetation fluid. That's what avoids that all above ground biomass goes from being at a state where it does not fire easily to suddenly just burn up. And what we're seeing is that you lose green water. Now, what is it that determines the amount of green water? Well, of course, it's precipitation, but it's not only precipitation. It's also evaporative demand. So if you have higher temperatures in the atmosphere is more thirsty and sucks up the moisture in the soils. And finally, which is the classic story of the Dust Bowl in the US in the 1930s, when you destroy your surface area of the soil, so you cause crusts and you lose organic matter, the soils can no longer hold green water. So it neither infiltrates, so it just runs off as degrading blue water, erosive, gully-forming, massive degrading water. And even if it infiltrates, if you don't have enough organic matter in the soil, the water cannot be held. So is there a risk that you see trends of desertification, like in the Central Valley? The answer is yes.
Although the atmosphere holds more water vapor as the world warms, what tends to happen is it comes all at once in a very large amount. And so you get these big sort of gaps between heavy precipitation events. And what this means is incredibly difficult to then store that water. So what we have been relying on is a sort of a steady set amount of water through the year. Now we're moving to a situation in many regions, not all regions, but in many regions, where you get more water over the year, but it just comes all at once or several times in a year. That's very difficult to plan around as a farmer. It's very difficult to know when to sow, when to harvest. So that becomes a real struggle. As that starts to happen, I can imagine that in a lot of countries, we'll be starting to use more and more groundwater. So this is the water stored over potentially even millions of years underground, and then extracting that water up and using that water on the land. Well, that's not a renewable resource, and it's not being recharged in the same way by the water cycle. And so you're ending up in a situation where eventually that water will run out.
If you think about the world's global freshwater, 7 in 10 buckets of water are being used in agriculture. So in other words, at one point, they will go through a crop. And rice is probably the most predominant crop. Roughly half of all the fresh water that we consume globally somehow is linked to the #1 food staple in the world, which is rice. So very water dependent. All the other crops could be irrigated or not. Frankly speaking, that depends on where in the world farmers operate. It also depends on their ability to mobilize fossil fuels to pump water out of the ground.
if you get a trend line where you step by step, year by year, get a lower and lower green water holding capacity, meaning basically you're losing organic carbon in the soil. So you come back to carbon actually. That's quite interesting, that the best thing you can do for climate and for food production, for the resilience of agriculture from a climate perspective, is to suck up more carbon in the soil. And if you do that, you build more organic matter, you get more green water, you get more green water holding capacity, and you have less fires. What's happening now is that this organic matter is burned up. So it is oxidated, it disappears, the green water holding capacity goes down, soils get drier, and even if there's rainfall then, they just get self-drying. And that is the desertification trend that we fear.
In some countries where we get sort of drying as well, so in the southern Spain, for example, which is likely to become more and more of a desert as we move into the future and as we get to higher temperatures, then we're going to be wanting to use more and more of this groundwater, and it just simply won't be there anymore. And so we'll have a collapse of the food production in those regions. So when we do look at some of the crop modeling and the climate modeling in the future, one of the ways we can deal with a hotter world is more irrigation and more water, but we won't have that water.
Where we are now in the temperate north, you'll also see major impacts, potentially actually even larger impacts than on the equator. But agriculture is more likely to be able to cope with that because you have so high degree of freedom here. You operate the agricultural system in Europe, for example, in regions that have such a secured freshwater supply throughout the whole year, that even if you change that by extreme events, you're more likely to be able to cope with it. So I'm very worried about what's happening, what will happen, and what's happening already today with agriculture in the most vulnerable regions in the world, meaning the semi-arid, dry, subhumid, tropical regions in the world that are most likely going to lose.
One of the first environmental assessments that was ever done on all global environmental changes and its impact on humans. There we looked into the future of the planet and environmental change and human well-being. And what we are basically doing right now, the way the current system is set up, is we are banking on the environmental system being able to take the pressure for a long time so that we don't have to think about it. We know that the environmental feedback is already biting us back through climate change, through all the planetary boundaries that we are overstepping, biodiversity loss, water issues. Yeah? The question is, or the injustice in the system is, it's currently biting the poorer people in the global south before it bites the global north. So this is why there's so much talk about justice and equity and fairness in the system right now, because what we are doing is we are really putting the burden on the poorer people and future generations.
We have been taking a constant increase of agricultural yield for granted. And we are now entering a phase where this will be completely different, where not only the cyclical effects become more extreme, but the overall productivity growth kind of declines to a point that we might even see a complete end of productivity growth. As a result of that, inflation will no longer be cyclical in the food space, but will be a constant problem for humanity. It will become stubborn. In rich countries, that could completely change political systems. In poor countries, it could lead to a higher increase in hunger. And the data we are seeing already, the data we are seeing in this decade, indicates that food inflation and hunger are on the rise. And I think, unlike what we have thought, humanity is at a point where our goals to end hunger and our, I think, belief that food inflation is just something that happens here and there, but is not a constant, need to be corrected.
We literally, in the US, you can get any kind of produce all year long. That makes no sense, except for it's happening, right? There's not a lot of countries in the world where this happens. And why does it happen? Because we import from every country in the world, so you can literally get anything, anytime. That is the resilience of the food supply chain that we have. Sometimes it breaks and no one pays attention. So I don't know if you remember, but a few months ago, there was the bird flu disease for chickens. There were no eggs, and eggs were literally, we'd go to the supermarket, no eggs on the shelf. Eggs would cost 10x as much. People were frustrated, and they completely forgot about it yet again. I just went to the supermarket and eggs are super cheap and they're there now. Nothing happened. Nothing happened in that point of time of the crisis. Unlike maybe in COVID, where people did wake up. And again, those learnings, how many of those did we keep, right? So these things happen all the time. But unfortunately, I think people just need a real wake-up call. And even just seeing those supply chains falling apart for a small period of time doesn't help people understand that they're quite vulnerable. Like, one disease can wipe out an entire crop. That is just the way it works.
When you look at the historic examples of famines, then they're usually always caused by multi-year, multi-region crop failures. The effect of that to the extreme could be a famine. The constant and stubborn effect we have to now adjust to is food inflation. In the year 2000, Africa imported food at the value of roughly $10 billion. 25 years later, at the end of 2025, this bill has been inflated to $100 billion. So it's a 10x. Prices went up 85%. So it's significantly more than traditional price increase. Why is that? There's almost no country in Africa at the moment where agricultural productivity keeps pace with population growth, with urbanization, and with wealth gains. These are the three factors that increase the food demand. The political consequences will be dire. There are 3 countries in Africa where in 2023 more babies were born than in the whole of the United States or in the whole of the EU 27. The huge demographic divide, the growing baby boomer generation in Africa, will be at the forefront of food inflation, and their future will be determined by our ability to find solutions to this problem. Instead of investing in rural development, Africa is a continent that has a huge potential not only to feed itself, but like Brazil, to become a food exporter.
The area that I worry about most is the big megacities in sub-Saharan Africa, the Greater Lagos, the Kinshasas, the Dar es Salaams and things. It's insufficiently realized in policy circles quite what has happened in urbanization in Africa over the last 20 or 30 years. And it's no coincidence that these big megacities are by the sea, because they are supported by international commodity trade. Yes, there is some local agriculture, but not enough. So I worry that there is a disruption of global commodity trades, and that the groups that lose out are these big sub-Saharan megacities. And were you to get significant food shortages in these big cities, that would have immediate social, economic ramifications.
Global food trade, which today represents something like, the highest estimates is roughly 25% of staple food crop provision. So most of the food is actually produced locally, domestically, but those 25% will very likely increase, because we are moving very rapidly into a future where simultaneously, not only in one place on planet Earth, but most likely multiple places on planet Earth will be affected by massive extreme events, fires, droughts, floods, dry spells, that will collapse or totally destroy the food production capacity at that moment in time, which means that either those societies suffer tremendously, or you compensate it, you buffer it with trade. And I think we're moving into a direction where we inevitably will see food trade being an absolute necessity to buffer rising volatility on the global food markets.
We need global food trade because we will see food shortages, productivity losses in different regions of the world at a larger scale than today, more often. And the only way to correct for that is to ship agriculture products from one part of the world, where there maybe is a surplus, to another part. So food trade is not the problem, but is absolutely necessary to avert catastrophes. At the same time, countries need to focus on improving their own agricultural yields in order to reduce the bill for importing food.
Essentially, all studies today show that the only sustainable way forward for all food production, I mean, be it animal-based protein from livestock, but also crops, has to occur on existing land. We cannot continue expanding because we depend totally on the little intact nature we have left to buffer the climate change impacts that we have caused.
There are 500 million smallholder farmers who live in regions that do not have really contributed to the problem of climate change, but that are fully exposed to it. A typical human in sub-Saharan Africa uses as much electricity per year as an average American fridge. But these people are basically exposed to the climate extremes in ways we can't imagine. And we can help these communities without moving a lot back and forth, just with the help of digital tools and the financial markets by providing crop insurance to them. That's the number one thing we need to do, and it would make a huge difference in the lives not of thousands of people, not 100,000s, but up to 500 million of humans. So a very important thing. It will also keep them on their land, and it will enable them to apply their ingenuity to solve the problem. Because if they have a security of income, they will be able to produce higher yields over a longer period of time. Priority number 2 is that we need to have a conversation about the amount of money we invest in agricultural research. Bayer is the world leader in that space. We spend $2.5 billion every year in agricultural research. But we see agricultural research from a public funding perspective as well as from an industry funding perspective on a path of decline. So the idea that we have billions, hundreds of billions to build data centers or to do all kinds of other things, but we don't have the money to invest in agricultural research when it's needed the most, is one that is really puzzling me. So Bayer is the world leader in industrial investment in R&D, 2.5 billion euros actually a year. If you think about the global network of agricultural research centers, the CGIR, they are roughly a third of that. So that is sort of the public investment, and that had a huge impact. So Norman Borlaug, who won the Nobel Peace Prize for his work on plant breeding, has been able to do that as a result of this public CGIR network. CIMMYT is a place in Mexico where he started to really breed the kind of wheat crops that avoided a major hunger crisis in the early 1970s. And this research was responsible for me growing up at a time without a major hunger crisis compared to what my parents, my grandparents, and every generation before experienced as a staple in their life. So if you think about this, we don't really know how much we are investing, but compared to a lot of stuff that is going on in other places, it's not very much. The NIH budget is $80 billion. National Institute of Health, one agency in the United States, spends $80 billion in the health space. We do not have investments that are even close to this. Agricultural research needs to be prioritized, but there is no conversation about it, and there are only a few people who realize how important that is.
All the investments in crop breeding, in research and development, has been focused very much on productivity and yield increases for the few basic staple food crops we have, you know, the maize, the rice, the millets, the sorghums. And what we need to shift in the future is to put equal amount of investment into building more resilient food crops, where we emphasize more root depth, canopy, above ground canopy, not only the harvested parts, the kernels that leads to the bread or the pizzas. And this in itself is a great opportunity now that we have all these AI technologies to speed up the pathways and even using genetic tools. So I think we are in a quite good position actually to transition towards more robust, resilient agricultural systems.
One good thing about modern agriculture is that it is an inherently adaptive practice. Humans choose which crops to plant when and where, and they can make different decisions over time as the climate evolves. So in many ways, cultivated agriculture can change more quickly in response to climate change than natural vegetated ecosystems, because we're actively making choices about what to plant and when, and there are scientific ways to essentially produce varieties of different staple crops that are perhaps more adapted to hotter temperatures or drier soil conditions or different plant pathogens, and to essentially speed up the natural evolution process to bring that about.
Ecosystems tend to be remarkably resilient. If you have a trend of clear desertification over a long time, you just are gradually degrading, you're plowing your soil so much or organic matter disappears, which means that we turn the soil each year, which has been very effective for weed control. But what the impact in water scarce, high temperature, dry regions is that you expose your soils to the sun and you burn carbon. This leads to two consequences. It causes plow pans, which roots cannot go through, and it burns up your organic matter in the soil, which can hold the moisture in the soils. If you abandon the plow and introduce what is defined as conservation agricultural systems, so minimum tillage systems, very well established, 40% of agriculture in the US is different forms of zero tillage systems, where you either don't turn the soil at all, you have direct planting systems, you copy nature basically, or you even use what we've been developing over many, many years, decades in large parts of the world, are different forms of so-called rippers and subsoilers, which are just knives that just open the soil. So you don't turn the soil, just open it, and then you plant your seeds in the cracks, and the opening leads to better infiltration of rainfall. So that's one part of the technology. The second one is you need to get more biomass into the system. So you don't want to have monocrops. You don't want to do maize. You want to do maize, cowpeas, have nitrogen fixating cover crops. You want to have a very, very dense canopy cover in order to build more organic matter, but also protect so you don't get so much evaporation losses. And then the third part is that you want diversification. You want to have many different crop species. It looks messier, but it is fundamentally a much more robust system. And that has been introduced in large parts of eastern part of South America. You have what is called mulch farming, operating at very large scale. So this is no fantasy. This is something that can be introduced at large scale, and I would even argue as a necessary step.
When you bring diversity back on field, so you're growing several crops in between one another, they typically work in sort of synergistic ways. They work to help one another out. So, for example, legumes might be bringing nitrogen into the soils and improving the soil architecture. Squashes might be improving the consistency of the soils and giving the field structure. So it's about not treating land necessarily as a factory and more as an ecosystem, that you're working with the land and you're working with that environment to produce food in the sort of healthiest way for us and also for the planet.
One of the major emissions from agriculture are methane emissions. While they're super strong greenhouse gas, they also have a very short atmospheric lifetime of just about 12 years. Which means that if we reduce our methane emissions, this leads to a very fast reaction of the climate system and fast decline in temperature. And now this becomes particularly important if we see that the peak warming in an ambitious scenario should come rather soon. So we don't want to go too much above the 1.5 degrees, so we have to rapidly reduce emissions. And there, reducing the consumption of livestock from ruminant animals like cows, sheep, and goats is a very quick solution.
One of the big challenges we have is that significant parts of our diets are based on industrial processes where we have value chains that depend very much on feedstocks going into intensive meat industries, but also fish production that cause upstream degradation of ecosystems, deforestation, cutting down of rainforest, translating that to soybean production, which then goes into feed for ruminant meat, beef production, which then in turn leads to unhealthy overconsumption of subsidized cheap meat, which then leads to waste and eutrophication downstream. So you have this linear system which is, irrespective of climate change, not only unsustainable, but also unhealthy.
Main things that we can do to make the global food system more resilient is to really make that system smaller and more robust. And really the only way we can do that is shifting what we eat to more plants. If you were to eat this diet in rich countries, you would save an area the size of the EU, because our current system takes up so much land, and if we were to produce plants instead, it would be much less land. Now, if we were able to return that land to nature, then we would be able to draw down on that land about 14 years of global agricultural emissions.
When you scan off the literature on healthy diets, it's not as if science says that everyone has to become vegan or vegetarian. The best assessment today is that a flexitarian diet, where we shift over to reducing animal protein intakes and add more plant-based proteins, while developing countries in the world tend to already be more or less within the flexitarian dietary regime. So it's largely a northern problem that we are over-consuming not only at unhealthy volumes, but also unsustainably produced animal-based livestock products, which again destroy ecosystems all the way through that chain of production.
We are now able to understand cellular systems in ways we could never before. We can now accelerate breeding in ways we could never before, which means we can be faster also in the adaptation to climate change. And we can figure out solutions to protect crops that we did not have at our fingertips even 2 or 3 years ago. This convergence of artificial intelligence, biology, and chemistry is truly revolutionary. So with all these conversations about artificial intelligence, I think we should also look at sectors that are not intuitive in the space. Our ability, for example, to understand the three-dimensional structures of proteins has changed in radical ways. In the early 2000s, a group of researchers got a Nobel Prize for describing a three-dimensional structure of one protein, arguably a very important one, the ribosome. In 2024, the Nobel Prize was awarded to a group of researchers that, with the help of AI, can describe the three-dimensional structure of 280 million proteins. Biology is completely revolutionized. And this helps us to look at living systems in the health space, but it also helps us to look at living systems in the crop space, to look at the soil microbiome in different ways, to look at ways to capture carbon in ways we haven't done before, to breed crops that are much more resilient against extreme weather, to breed crops that are more nutritious than the crops we grow today, to focus our breeding not only on an ever more narrow number of crops, but to broaden the basket of food-generating crops. All of that is possible because we are at the verge of a truly revolutionary change, which is why the bio-revolution is one of the things that I feel is underestimated in what they can contribute.
mushrooms are a very, very resource efficient crop. So the opportunity from a climate perspective for mushroom production or fungi production more broadly is the ability to use very little land, very little water, and still produce a really significant amount of protein. So being able to provide that rather than some of the other ways that we produce it with outdoor cropland or with animal production that is eating grains from cropland, that just takes orders of magnitude more land and more water, more resources. Effectively, the role that fungi play in nature is they take biomass. So you could think of a fallen tree, you could think of leaves on the ground, and they transform that into something new. The thing that they're transforming it new into in nature is usually soil or the components of soil. But for us, we know that certainly mushrooms, but fungi more broadly, can transform that into protein. They could transform that into materials, into chemicals, things that we really value. The reason why that's so interesting for us is you're basically getting, from a resource perspective, from a planet perspective, free protein, free animal feed, free mushrooms, free organic chemicals, all of these without needing more land, with needing very little water, very little energy usage as well. It's helping to close that supply-demand gap between what humanity is asking from our land and from our food system and what agriculture is able to provide. The technology that Hedgehog is developing is a full-stack, comprehensive approach to cultivating fungi. The first part of that technology that we've already developed is cultivating a microbiome on the substrate that the mushroom grows on. The microbiome that we cultivate is actually protecting the mushroom from competing molds and bacteria that want to come in and basically outcompete the mushroom for its nutrients. The benefit of that is that enables us to grow it at 1,000 to 2,000 times the scale of how mushrooms are produced today. And when you're able to grow it at just that much larger scale, it significantly drops the operational burden, significantly drops the amount of labor, and lets us produce them for today around 70 to 75% lower cost than existing methods. So in terms of production of protein per acre, there's not really anything else that can produce as much as mushrooms. So for example, if you took a cattle feedlot and you said, well, in 1 acre of cattle, we can produce much more protein than that, in some sense you would be right, but you would need thousands of acres of corn and soybean fields that are really feeding those cattle. Or similarly, for if you had a aquaculture or fish farm, you similarly could have a very small square footage of where the fish actually are, but you would be drawing from thousands of acres to actually feed those fish. For fungi, the only thing that you're needing as an input for them is agriculture waste products. You're not adding any more strain to the land. You're not requiring additional acreage to support the farm. The only thing is you're taking residues, byproducts, waste products from agriculture that are already being produced, that are currently free, not being used, and you're taking those and feeding them into your facility, and you can get tens of thousands of pounds of protein per acre per year. So in that sense, in terms of true strain on the environment, true amount of incremental land that would need to go into the production system, there's not another solution that would be even remotely close to the amount of protein that you could pull off of 1 acre as a mushroom farm.
I am pretty much an optimist when it comes to thinking how biology and modern technology can contribute to food production, especially genetic improvement, which originally you could only do on the few crops that have been intensively studied: soy, rice, wheat, maize. That these techniques are now becoming applied to other crops, the millets, the sorghums, the cassavas, the so-called orphan crops. I'm optimistic about how we can breed even the traditional crops to grow better in a more constrained environment. I'm optimistic about some of the technological advances that will enable us to produce food more efficiently. So utilizing data, utilizing everything from drones to satellites, the sort of so-called precision agriculture.
The magic with plants, and this is what gets us so excited, is they're actually very active in their environment. So unlike humans and animals that over time could just run away from problems, plants over millions of years have been dealing with their problems without being able to mobilize. So what they've done is created very sophisticated mechanisms to protect themselves. And people talk about plants communicating, and the reality is it's true. Plants communicate through their leaves, and they send hormones. They have different vibrations and mechanisms to tell each other what's going on in the field. What we're interested in specifically is their ability to protect themselves through their immune system. We look for the genes that the plants activate to protect themselves, and those genes are the earliest indication of any kind of stress impacting the plants, which is the reason we target them. We can talk about fungus specifically because that's our first product, is a soybean that signals fungal pressure. They will start activating genes that protect them from the fungus that's trying to eat them. What we do is we engineer the crops and we connect to that gene a fluorescent protein, meaning we teach the crop, when you're reacting to the fungal pressure infecting you, start producing this new protein that doesn't otherwise occur in the plant. So when that protein then starts to light up, we know that the plant is attacked by fungal pressure. And the way we capture that is through optical equipment, because we're creating an optical fluorescent signal. So basically we can capture our signals from anywhere from, field equipment close by to satellites in orbit, and the idea is to be able to enable as many different modalities and flexibility for farming. We don't actually know if there's an infection in the field. There's no way for the plant to provide that information without what we do. And if you think specifically about soybeans, it comes down to practicality for farmers. They need to make a decision about protecting their crops with fungicides mid-July. They will not have the right information to make that decision today until mid-August when the symptoms appear. So they, by definition, have to go in and make a decision to spend a lot of money on chemicals before they even know if there's going to be any value in that and if the disease is going to take hold. That's what we fix. We provide them the right information. There is a disease infecting your crops in mid-July. Where is it? What is the disease? What's the right product? So they can go and act with that information.
In one sense, the challenges of feeding the world in the next couple of decades are really complex, but they're also really simple. However you divide the food system up, I tend to think of it as supply, demand, governance, and waste. It's not an either-or. You just need to work on all of them. So you need to work on the technology of closing yield gaps, increasing the yield ceiling. We have to have difficult conversations about diet change. We will not get to net zero eating the amount of meat and dairy that we do at the moment. That's a really difficult conversation to have for governments, especially as so many people's livelihoods depend on producing meat and dairy. We have to talk about just transitions. Waste, in one sense, it's straightforward. We need to bear down on waste, but waste is also complex. Quite a lot of waste makes economic sense. And then governance is complex, especially at a time of retreat from multilateralism. So I am, as I say, guardedly optimistic that we can square these circles, but we have to move fast, we have to move faster, and we have to bear in mind that there may be some really nasty shocks that we're not aware of at the moment.
I would argue one of the most exciting scientific findings we have today in the whole food system transition, that when we combine the best science on healthy diets, reducing food waste, we have 30% of our food on average being unnecessarily wasted. And third, investing in practices that are well known and that can be scaled to transition from unsustainable production practices to sustainable production practices. And what that means is production practices that does not sacrifice yield levels, but still can build more organic carbon, cycle more nitrogen, be more water use efficient, have better diversity in plant plant diversity in agricultural landscapes. And when you plug all that into models, and we in the Eat Lancet Commission work have done the first full-scale model into comparison. We had 10 modeling groups applying the best future scenario analysis they had. And in the end, the results of that shows the following, that if we all eat healthy food, we would have a significant positive impact on the planetary boundaries on nitrogen, phosphorus, fresh water, land, and greenhouse gases, but we will still not be in the safe operating space. But if we combine it with reducing food waste and sustainable production, we would essentially come back almost into all the planetary boundaries except greenhouse gases, because you would still have a fossil fuel-based driven food system. So if you then add, assuming that countries would basically do what they've promised in terms of the energy transition, then ta-ta, there you are, you're back into the safe space. So the combination of an energy transition, healthy food, food waste is reduced, and sustainable production practices, all of which is doable, all of which is scalable, all of which is proven to work, all of which gives social and economic benefits. Combine that together, and you're actually able to transition back within the safe operating space within the next 30 years. That is a good plan.
Some solutions are really simple. Some solutions are very, very basic. And other solutions are sort of the super high-tech future science fiction kind of thing. But what we have at our fingertips is more than enough to solve the problems. And if there's one thing true about agriculture, we wouldn't be more than 8 billion people on the planet today. It's a sector that has been very, very capable in adapting to new situations. If there's one group of people on the planet that is really good at that, it's farming communities. And that, of course, is an asset we should not only support, we should only bank on in helping us to solve some of the areas of the climate crisis. So in the future, I can see Africa being a continent that is a net exporter of food. In the future, I can see farmers not being emitters of carbon, but drawing down carbon. And in the future, I can see a world where hunger goes away. But all of that requires an absolute focus on defining the problem that climate causes in our food system and an absolute willingness to do something about it.